guys, there were 5 equations that I gave you. You had to draw all 5 graphs. So you have to find the y-intercept and the x-intercept. So you can see my working there on the side. Once you have your 2 intercepts, you're going to plot those points and connect it. Yes. What day? Fine, you have to do work. Yeah, it depends on the question. Sometimes I'll say calculate the x-intercept when you want to see those steps. So just say draw the graph and you just look at it. Yeah, it's fine. You can leave it at 3 over 2. You can actually have 1.5 or 1.5 or I just want to reiterate that if you don't do your homework for this, you're not going to be able to do it in just some hands. I know the last test went better, but that doesn't mean that now you need to stop. You can just stop working. It's still the same people not doing homework. And we're in September already. I hope the same people that have not been doing homework for the entire year did not choose maths for next year, because we won't pass if you're not doing homework. I'm not speaking to the minority, but it needs to be said. Yes.
For the x-intercept, you have to like the equivalent is one and all.
So that's what I was asking. You don't have to. You can either 3 over 2 or you can actually 1.5 as well. Yeah. Are you guys struggling with the fact that 3 over 2 is the same as 1.5? So x equals, like, do you want me to explain this or like you not understand why I wrote 1.5?
Yeah, I think
It's fine. Yes, it's fine. I've said now twice already that you don't have to write it as 1.5. Guys, 3 over 2 is 1.5, hey? It's the same thing. So you can write, I'm saying it now for the 4th time. You can leave it as 3 over 2 if you want to, but where you're plotting it, it has to be at 1.5. So you do need to understand that 3 over 2 is 1.5 in order to put the point in the right place. Yes. No, you don't have to write that. No, you can just do the calculation. Yeah. Okay, number 2. Can I go? Number 2 is a bit easier because your solving for x wasn't as complicated. All right, for your y-intercept, remember guys, for finding the y-intercept, there are 2 methods. You could either just look at the constant term, which is -1, and that is your y-intercept, or you can make x equal to 0. So I wrote here 2 methods of finding the y-intercept. You can either do that or this one. Okay, you don't have to write down both like I did. So you're just going to say C is -1, therefore the point is 0, -1. Or if you didn't write that, then you're going to show that you are making x equal to 0. Okay, you don't have to show both of these methods here. But your y-intercept is -1, and then your x-intercept, we always make y equal to 0 there. So if you have 0 equals -x minus 1, I just moved the -x over and it became +x. Now guys, when you're drawing your graph, you have to label these points. If these points aren't labeled, you're going to get 0. Okay, even if I can see on the notches, you have to label them, please. No labels, no lines. Any questions on that one? Okay, there is number 3. Y equals 4x plus 2. So the constant term, the y-intercept is 2. Or you can just make your x equal to 0. So you're going to get 4 times 0 plus 2, which is 2, and you get that point. Then for the x-intercept, you make y equal to 0. So in your equation, you make y equal to 0. Then I moved the 2 over. It became -2. And then you must divide by 4. And guys, if you can't do that in your head, please type it into the calculator. -2 divided by 4 is -1/2. And if you're having trouble with plotting these points, remember, if it's a y-intercept, it has to be on the y-axis. So somewhere on that line where it's equal to 2. All right, so on the y-axis at 2, and your x-intercept has to be on the x-axis at -1/2. Okay, so there's my 0, there's my 1, so you can just kind of guess where -1/2 will be. Again, we have to label both of those points, very important. Okay, number 4. There is number 4. So your constant term was 6, so that is your y-intercept. So on the y-axis at 6. X-intercept, you have to make y equal to 0, so you can look at my working there. Now guys, for these graphs, when we mark them, we give you 1 mark per point. So if your y-intercept is correct, but your x-intercept is wrong, you will still get 1 mark. Okay, so the y-intercept is the easier one to find, because either you just look at your constant term, the number in the equation, or if you make x equal to 0, that's easy to calculate. And for that, you will get 1 mark, but it has to actually be drawn. Okay, you can't just write y-intercept is 6 without showing it on the graph. All right, so you have to show it on the graph and you will get that mark. Any questions on number 4? Right, there is number 5. Y equals 3x minus 1. So y-intercept, again, the number, the constant term in that equation is -1. And then for your x-intercept, you have to make y equal to 0, and then you solve for x. And in this case, we got a third. So that's another one that you just kind of have to guess. So if you have 0 and 1, you can kind of guess where a third will be, right? A third of the way in. I'm not going to sit there with a ruler and check that you plotted it exactly at a third. It's fine. Just kind of guess. Okay, as long as you label it, that's the most important thing. Okay, if you are done there, you can write a new heading so long. The gradient of a straight line. Okay, now I've mentioned the word gradient here before, but we haven't actually discussed it at all. Just a reminder, if our standard form is y equals mx plus c, remember c is the y-intercept, but m, the number in front of the x, the coefficient of x, is your gradient. Another word for gradient, it's not the official term, but it means the same thing as the slope. Okay, now we're going to start discussing the formula for the gradient. I'm going to show you how you can calculate the gradient if they ask you to. And we have actually written this down before. The gradient is equal to your change in y over change in x. So if you have 2 points, right? I'm going to write it like this. I'll explain to you now what I mean by this. If we have point A and I'm writing the coordinates of that point as the x value of A and the y value of A. Okay, that's why there's a little subscript there. So those will obviously be numbers. So A could be like the 0.12, for example. Okay, so this is going to have an x value of point A and a y value of point A. And then if we have a second point, and that's what we've had every time, hey, when we've drawn our graphs, we need 2 points to actually draw that graph. It's the same for the gradient. You need 2 points in order to be able to calculate the gradient. So if B is also a point, but it's the x value of B and the y value of B. Again, those will be 2 numbers. Okay, we are going to do examples with numbers just now. Then we're going to calculate our gradient in the following way. And this is more of a formal formula. All right, this is almost like an explanation. This is the formal formula. The gradient, and I'm going to write as a subscript of AB. When we talk about the gradient of a line, we can also say that it is the gradient between 2 points on that line. I'll show you some actual pictures just now. So the gradient of AB, or the gradient of the points, or the gradient between the 2 points, the gradient of the line connecting the 2 points, you can use all sorts of different terminology, is going to be change in y at the top. All right, so the one y value minus the other y value. That's what we're going to do. We're always going to take one y value, so the y value of 1 point, and we're going to subtract the y value of the other point. Then we have to divide that by the x value of that same first point. All right, so if we took the y value of point A and we minus the y value of point B, we have to do the same with the x values. We have to do the x value of A and then minus the x value of B as well. Okay, so you're going to find the change in y. So one y value minus the other one, divided by the change in x, one x value minus the other one. But guys, you can also actually do it the other way around. So we can also calculate the gradient of AB by saying the y value of B minus the y value of A. It doesn't matter which one you start with. You can start with either one. But like I said before, if you're taking the y value of B and you're subtracting the y value of A, you have to do the same thing with the x values. You also have to take the x value of B and subtract the x value of A. Now, I just want to look at the graphs that we drew for homework, and I just want to discuss their gradients with you, just so that we have a better idea of what it actually means. If we're looking at this graph, what is the m value in this equation? What is the number in front of x? 2. That means that the slope of this line is positive 2. Now, guys, do you remember when we did this first note on the straight line equation? I wrote here, so this is what we did, I don't know, it was sometime last week. We wrote that if the gradient, the m value, is bigger than 0, positive, then our line is going to look like that. Do we see that that's what's happening here? Our m value is positive 2, and the line is going up. We call this an increasing line. Right, that will always happen. You have a positive slope, right? So like a slope of the mountain, when it's positive, you're going up the mountain, all right? When your marks are increasing, when your marks are on an upward slope, they're going up. They're increasing. All right, so we can see that here. Let's make a little note. I'm going to write here the gradient is 2. So the gradient is positive. So our line is going to look like that. Now guys, can I write 2 as a fraction? Okay. 2 over 1, hey? Do we agree with that? 2 over 1 is the same as 2. Okay, so let's just write that as well. The gradient is 2, yes, but I can write it as 2 over 1. Now it looks like my formula. My formula is saying, oh, where is it now? Sorry. My formula is a fraction. Do we see that? Okay, so the formula for gradient is change in y over change in x. So how we can interpret this is, as my y values from one point to the next are changing by 2, my x values will change by 1. All right, so what that means is if I'm going from this point, if I go 2 up, 2 units up, right? Are you following? So 1, 2, and then I go 1 unit to the right. That should give me a point on my graph. Okay, we're going to do a lot of work with gradients. So if you're confused, don't panic. I'm saying here that if it's 2 over 1, that means that for every 2 units, and because it's positive 2, it's going to be up. Right? If it was negative 2, it would be down. We're going to talk about that. So for every 2 units that my graph moves up, the graph also has to move 1 unit to the right. Again, because it's positive 1, I'm going to move to the right. If it was negative 1, I would move to the left. Okay, again, we're going to talk about it a lot. So you should be able to see this if your graph is drawn perfectly to scale, all right, which it might not be, that's also okay. But if I'm going from this point on my graph, I should get another point on the graph if I go 2 units up and 1 unit to the right. Okay, and you see that if I do that, I do actually end up on my graph. Yeah. Okay, the same thing can then happen from this point. If I go 2 units up and 1 unit to the right, I will again get another point on the graph. Okay, they're not points that I plotted, but they are, you know, the graph is going through those points, the line. Okay, so that's one thing that's happening with that one. If we look at the next one, number 2, what number is in front of x here? -1, right? This graph has a negative gradient. Do you see the graph is going down? It's a decreasing graph. It has a negative slope. So the gradient here is -1 over 1. I'm going to write it like that. -1 over 1, is that the same as -1? Okay, -1 divided by 1, yes. Now guys, what this is saying is that for every 1 unit down, because it's -1 now, hey? My graph will move 1 unit to the right. And that should then give me another point on the line. It might not be the points that I've plotted, but it will be a point on the line. Yes. So -1 is the same as -1 over 1. So I'm just writing it as a fraction so that it fits my formula for gradient. Okay, but it was actually just -1. So let's look. If we're going from this point, -1 at the top, so I'm moving 1 unit down and then 1 unit to the right. Do we see that it gets me to another point on the line? Actually, the point that we plotted, right? From this point, if I'm again going 1 unit down and 1 unit to the right, it's again getting me to a point on the line. Okay, we are going to use that method later on to actually draw graphs, which is why I'm showing you now. So we're just discussing for now, so don't stress. Just right here, the gradient is negative. So my line has to look like that. It has to be a decreasing line. Okay, if we look at the next one, what is my m value? My gradient is 4. How can I write 4 as a fraction? 4 over 1. So my gradient is 4, yes, but we're going to write it as 4 over 1 so that it fits the formula. So this one is saying that for every 4 units, and now because it's positive 4, it's going to be up, hey? So for every 4 units that I go up, I also have to move 1 to the right, and that will then get me another point on the graph. Okay, now my graph is quite small, the one that I've drawn here, so we might not be able to see it. But let's go from, I'm actually just going to extend it a bit. I'll just grab my ruler. All right, I'm going to go from here. This is the point, if I read it off on my graph, it looks like this is the point -2. So it's -1, sorry. -1 on my x-axis and -2 on my y-axis. Okay, I'm just reading it off. I'm just seeing that it's in line with -1 and it's in line with -2 there. So we're saying that from here, we're supposed to go 1, 2, 3, 4 units up, right? And then 1 to the right. Do we see that we get to another point that's on the line? Okay, and it should always happen like that, guys, if that is your gradient. Again, it's a positive gradient, so do we see that the line is increasing? Now, guys, I want us just quickly to compare the first graph and the third one. Right, they both have positive gradients. Do we see they're both increasing? But isn't this one steeper than the first one? Right, if we're just thinking in terms of whether it's, in terms of steepness, do we see that this one has quite a gradual slope? It is quite steep, but not as steep as this one. Hey, this one is going up a bit faster, I suppose. All right, now guys, that is because the gradient for this one is a bigger number, right? A gradient of 4 will give you a steeper slope, a steeper line than a gradient of 2. Okay, this is something you really need to be able to apply. We're just discussing how it works. All right, let's quickly look at 4. Number 4 was another one with a negative gradient. Do we see? Going down. Number 5, positive gradient, going up. Okay, I'm not going to write all of that extra stuff there now. I think you guys get the idea. Now, if they are giving us 2 points and we need to calculate the gradient, let's do an example. So, for example, find the gradient of the line through A, which is the point 2, -1, and B, which is the point 4, -2. So this is a completely different question from what we've been doing so far, okay? We have been finding the x-intercept, finding the y-intercept, and drawing a graph. All right, now they're giving us 2 points, and they're saying we must find the gradient of the line that will go through those 2 points. Now, guys, for a gradient, you need 2 points always, okay? Because you have to do one y value minus another y value. So obviously you need 2 y values, right? Then at the bottom of the fraction, you have to do one x value minus another x value. So you need 2 x values. Okay, so to find the gradient, you do need 2 points always. Maybe we should just write that. Need 2 points. Now, guys, they've given us 2 points here. We can decide, do we want to work with A minus B, or do we want to work with B minus A? All right, I'm going to write down both of them so that we can see that we get the same answer, regardless of which one we start with. But when you're doing this in a test or exam, you will have to choose. Which one do I want to start with? Let's start with A. All right, or let's start with B. So we are all possibly, hopefully, going to write down both options now, but in a test or exam, you only have to do one. Okay, so let's say the gradient of AB let's write down the formula. You don't really have to, but because we just started now, let's write it down. Let's say if we're starting with A, we're going to do the y value of A minus the y value of B divided by x value of A minus x value of B. Okay, what is the y value of A, guys? -1 minus the y value of B is -2. Put that in brackets, please, because we're minusing a negative number. Okay, so let's put brackets around that negative number so that it doesn't, so that we don't forget about that minus. Okay, that is the y value of A minus the y value of B. Then we have to divide that by the x value of A, which is 2, minus the x value of B, which is 4. Now, guys, what do you get when you do a minus multiplied by minus? This becomes a plus, hey? So this is actually -1 plus 2. What's -1 plus 2? -1 plus 2 is 1, hey? And 2 minus 4? -2. Now, guys, can I leave that minus at the bottom like that? No, we have to put it in front. Okay, so this gradient is -1/2. So if it has a negative gradient, how is the graph going to look? Is it going to be increasing or decreasing? Decreasing. Just draw a little thing there at the bottom just to show that. That's not a part of your answer, really. We're just trying to link everything up. Okay, or let's calculate it if we take the values of B first and then minus the values of A from those. So if we say the y value of B minus the y value of A over the x value of B minus the x value of A. What is the y value of B? Remember, it's xy, so the y value of B is -2. Now we have to subtract the y value of A, which is -1. So again, because we are now subtracting a negative number, let's put that negative number in brackets. Over the x value of B is 4 minus the x value of A is 2. Again, guys, a negative times a negative will become a positive. So that is actually -2 plus 1, which is -1 over what's 4 minus 2? 2. What do I do with that minus? Put it in front. Do we see that we get the same answer, guys? Yeah, you're always supposed to get the same answer. Okay, because it's one line that has one gradient. Whether you take from A to B or from B to A, you'll get the same answer. All right, again, it's a negative value, so it will give us a line that looks like that, a decreasing line. Okay, I'm going to hand out a worksheet quickly. That you can stick in so long. Yeah. I'm not sure. It depends on how I don't know, we haven't really spoken about next term. Sorry, I'm just trying to, it's a couple of different worksheets together. That's the one, yes. Okay, guys, you're going to have to complete this worksheet for homework, but I just want to help you with the first few, just to give you an idea of how you're going to do these questions. Okay, let's just quickly all look at this diagram that is on the right-hand side of the page. It is a bit alarming. There's a lot of stuff going on, but you should notice that each line has been labeled with a letter. Okay, so if we're looking for line A, it's that one over there. You're going to look for the letter that's next to the line. Okay, this is line A. Now, guys, in the first question in number 1, they're saying, write down the gradient of each graph labeled A to G. Did they give us points? Right, in the example that we just did, I gave you 2 points and I said, let's find the gradient of the line going through those 2 points. In this worksheet, they haven't given us any points, but they've given us the actual line. And what do we have all over the place on this line? We have lots and lots of points that we can read off. How many points do we need to find the gradient of any line? 2. So let's take a pen or pencil and let's identify 2 points on line A. Now, guys, they've given you grid paper, right? They're blocks, so they're easy to read off. So let's look at, if we're following line A, let's take, there's a point over there, right? So that is the point 3, 3. I've just chosen a point now. You could have chosen any number of other points. All right, so 3, 3. So let's write that down next to this. We have the point 3, 3. But to find the gradient, we need another point. So let's go to the line and let's find another point anywhere on this line, guys. What do we see? Oh, this is interesting. This line actually goes through the origin as well, right? What are the coordinates of the origin always? 0, 0. So we can work with 0, 0. So let's say 3, 3 and 0, 0. Those are 2 points. Again, guys, you could have chosen different points, right? It doesn't actually matter which 2 points you choose. It will give you the same gradient because we're finding the gradient of line A. So we can work with any 2 points on line A. Now let's calculate the gradient, guys. What do we do for the gradient? It's always y value of the one minus y value of the other over x value minus x value. Which one do you guys want to start with? 3, 3 or 0, 0? 3, 3. Let's make a little star above 3, 3 so that we know that we're going to take that y value first and that x value. What is the y value of the first point? 3. Minus, what is the y value of the second point? 0. Divided by, what is the x value of the first point? Also 3, hey? And the x value of the second point? Also 0. So 3 minus 0. What's 3 minus 0, guys? 3. So at the top I get 3 and at the bottom I get 3. Is this the simplest answer? What is 3 divided by 3? 1. There you have your gradient. Okay, is that fine, guys? You're going to do that for all of them. So before you can find the gradient, you need to look for the line, identify any 2 points on that line. Please write the points down next to the line that they gave you. Then you're going to do y value of the one minus y value of the other over x value of the one minus x value of the other. I'm just going to write that formula down. So m is going to be y value of 1 minus y value of 2 over x value of 1 minus x value of 2. Right? You decide which point to start with, like we did now. We decided we're going to start with 3, 3. Guys, if you started with 0, 0, you would have gotten the same answer. Because you would have said 0 minus 3 over 0 minus 3, which is negative 3 over negative 3, which again is 1. Okay, so it doesn't matter. All right, you're going to choose any 2 points and then find the gradient there. In number 2, they're saying now finding the y-intercept of each graph. Write down the equation of each graph a to g in the form y equals mx plus c. Now guys, in number 1, we're finding the gradient. What letter is the gradient in our equation in y equals mx plus c? The gradient is always m. So what we did here, when we're finding the gradient, we've actually found our m value. So please write down m is 1. So the gradient that you find in question 1, that is your m value in question 2. Now guys, do we remember that in this standard form, c is what? The y-intercept. So let's look at line A and let's see what is the y-intercept of line A. At what point does it cut through the y-axis? At 0. So the y-intercept is 0. That means that my c value is 0. So let's write that down. C is equal to 0. Your m, that's the gradient that you calculate in question 1. C, you're going to have to look at the graph, at the line, and see where does it cut the y-axis. All right, this value is the y-intercept. So you're going to have to go to the line and read that off. But now they're saying we actually have to write the equation. Okay, so that's something different now. We have to write down y equals mx plus c. What is my m value? 1. So y equals 1x, right? Do I write that 1? No. So therefore, y is equal to x. And then plus c plus 0. Do I have to write plus 0? No. So that is the equation of the first line. Y equals x, which is a bit funny. Hey, we haven't seen a line like that before. I'll do another one with you now, just so that you can see a different one. Okay, let's look at B. First, we have to find the gradient, then we're going to find the equation. Okay, so line B, let's look for B. On your picture, you need to find B. Do you see that it's the one that starts just below A? Right? Let's find 2 points on that line. Yeah. 4, 3. Oh, it's 4, 4 actually. There, do we see that? Yeah, 4, 4. Okay, so that's 1 point. 4, 4. What else? It's on B, hey? Yes? 0, 2. Good. Do we see 0, 2 is also a point on this line? 0, 2. Again, guys, you could have chosen completely different points. It doesn't matter. Okay, 4, 4 is one that we're choosing, and 0, 2 is the other one. Now we decide which point are we starting with. You guys want to start with 4, 4? Let's start with the one that we write down first. Okay, that's easiest, I think. So we'll start with 4, 4. What is the y value of our first point? 4. So we're going to say 4 minus, what is the y value of the second point? 2 over, what's the x value of the first point? 4 minus x value of the second point is 0. So 4 minus 2 over 4 minus 0. Guys, what is 4 minus 2? 2. And what is 4 minus 0? 4. 2 over 4, what's that equal to? A half. Good. So the gradient is a half of that one. So go to the next question. If our gradient is a half, then m is a half. Remember, the gradient is m. Now we need to find c as well. Remember, c is the y-intercept. So we go to our line, line B. Where does this line cut the y-axis? At 2. That's actually one of the points that we used. Hey, we used the point 0, 2, which was the y-intercept. So if the y-intercept is 2, that means that c is 2 for this graph. So c is equal to 2. Now we must write the equation. Remember, guys, you can highlight that maybe y equals mx plus c. They've written down the standard form there for you. Therefore, y is equal to mx. But what is m? A half. So it's going to be a half x plus c. Now my c value is 2. So plus 2. And there you have the equation of that line. Guys, if your y-intercept is negative, then you're going to have a minus for your c value. All right. It doesn't actually happen for any of these. We will talk about that again. But guys, do you have a bit more of an idea now of what you have to do for this? So first, find the gradient in number 1. You need to find 2 points on the line, and then you find the gradient. Then your gradient is your m value. You look for your y-intercept, and then you write your equation. Okay, then you're going to do the same for D to G as well. All right, that is your homework, guys. You don't have to do number 3 for homework. You're going to do 1 and 2 for homework only. We'll talk about 3 tomorrow. Okay, get going.